in physics there are two analogic equations. One is belonging to resistance, the other one is belonging to linear expansion. Let's explore. Now, in case of the graph over here, we find that y-axis is resistance, x is temperature. Now, as temperature increases, the resistance also increases. Now, I am sure we are all aware about why does resistance increase as temperature increases. This is because we know that every molecule has within it internal energy. So there's a bit of vibration on. Even if the material is stable, but the molecules inside do have internal energy, owing to which there's some vibration going on. Now, since this vibration is going on, now what happens is that the vibration is very low and the electron has to pass. So if the vibration is low, then the electron gets lots of opportunity to pass by. But if the vibration is fast, then the electron has obstruction for passing through, or the drift velocity is obstructed. Why? Because more of heat is applied to the material, owing to which the temperature rises, owing to which the internal energy of molecule rises, owing to which the vibration in molecule rises, and this obstructs the velocity, drift velocity, owing to which the resistance increases with rise in temperature. All right. So this is the reason why with temperature resistance increases. All right. Now, having understood, let's understand difference in resistance. Obviously, now we know that initial resistance would be low. R0 is at lower temperature and R is at higher temperature. So difference in resistance is directly proportional to initial resistance. All right. It's also directly proportional to difference in temperature. We can call this as del T also. Now we all know that when proportionality goes, we get a proportionality constant. All right. Now this proportionality constant is called as temperature coefficient of resistance. All right. So we get this. Now on solving, we need to get alpha. We need to get the equation in terms of alpha. So I take this entire stuff in the denominator and I get this formula. This formula is very much critical. We have got to keep it in mind for simple numericals that we get in JEE and NEET and CET also. The unit, obviously we will see that this would be ohms, this would be ohms, so ohms would get cancelled, and what would be, we would be left with is unit, that is per degree Celsius or per Kelvin. All right, this is what it is. Now let us also now the same thing can also be converted in terms of resistivity. Why? Because we know that resistance is equal to rho L over A, where rho is resistivity, L is length of the wire, and A is area of cross section of the wire through which current is passing. All right. So we can also, and so we know that resistance is directly proportional to resistivity. So this can coolly be, resistance can coolly be changed to resistivity. All right. So let's learn this formula well. All right. Now let us try and understand how is linear expansion also very much like resistance, increase in resistance. Let this be rod of initial length L0, and on heating it increases by del L and gets the length of L subscript T. T just indicates the temperature at which it has been heated. All right, LT. So LT minus L0 is directly proportional to L0, that is initial length. That's what we had seen in case of resistance also, where it was a R minus R0 proportional to R0. Then again, LT minus L0 is also proportional to difference in temperature. The same thing we had seen for resistance also. So when we combine together, obviously, as we had seen in resistance, Here also we get alpha, and these two combines together since they are directly proportional. So is equal to, we instead of proportionality we get alpha t minus t0 into L0. Now here alpha is coefficient of linear expansion of solid. So if now we want to get it in terms of alpha, that is in terms of coefficient of linear expansion of solid, then we just have got to take this into denominator as we had done in case of resistance. So we get this formula. So this formula also has got to be kept in mind, and unit of this obviously again here unit of length would get cancelled, and what we would be left with is per degree Celsius or per Kelvin. Alright, so it's all the same. So see, you do that resistance, you do formula for resistance and just apply the analogy for length, you will find the formula the same. So your effort is reduced. As we derived this equation for alpha, that was for linear expansion, we can also derive it for areal expansion, that is expansion in area, and we can also derive it for expansion in volume. We would just call it as coefficient of areal expansion, and in case of volume we would be calling it as coefficient of volume expansion, and the replacement would be of these things would get converted to area, and here it would get converted to volume. Alright, otherwise the formula is the same. And finally, what's the relationship between alpha, beta and gamma? Alpha is equal to beta by 2 is equal to gamma by 3. Just to keep in mind, what I say is keep it in mind as if it's alpha by 1 is equal to beta by 2 is equal to gamma by 3. So that helps you keep in mind the relationship between alpha, beta, gamma. We get quite number of numericals based on coefficients of these expansions and coefficients of resistances. So understand these formula well for better performance in your competitive exams.